We start off by showing the overall assembly of the device used to filter water. On the left, we begin with the gear and chain assembly connected to the mechanism, also connected to the pump. The pump is then connected through a hose to a watertight and airtight reservoir, which is then connected to a check valve, or rather an open-close valve, controllable by the user, to then force a flow into the water filter, which is the final stage shown on the right-hand side of the screen. Beginning with the gear and chain link assembly, we start by connecting the mass on the chain itself, where the potential energy will be generated. As the weight begins to drop, we then begin to cause a rotation of the gear, which in turn also causes the mechanism's arm to rotate and to create several strokes of the mechanism system. These strokes will then begin to pump in the system to create and compress the air. This compressed air, due to the continuous strokes of the gear and increased rotational velocity, will then compress the air contained in this watertight and airtight reservoir. This compressed air will continue to build in pressure until it causes the open check valve to be opened by the user at whenever they wish. When the user finally opens the valve, the compressed air forces the water through the pipe and consequently arrives at the water filter, causing the water to be filtered with the initial goal of converting the potential energy initially listed to final use of. Now that the overall function of the system as well as individual components has been explained, it is very important and necessary to be able to understand the possible improvements that can be done to improve the performance and weak links of the system. We first begin by looking at the gear. Due to the limited diameter of the gear and length of the mechanism itself, the length and duration of the stroke, and as well as its repetitivity, is also very limited. In terms of future improvements, we wish to greaten the diameter of the gear to be able to increase the stroke length and distance of the arm to compress more air. This would allow us to be able to compress more air for fewer rotations and be able to make use of the most potential energy contained in the system from the bag of potatoes. Moving on to a second potential improvement, we begin to look at better sealing. The current system for the sealing of the device is not bad, however could use improvements in areas where there are connections, also shown on the screen right now. In addition, the valve itself could use improvement in areas of preventing leakage, as when the valve is opened and the water begins to rush through, there is some leakage from the bottom of the valve itself. So therefore, a better valve would also help with preventing the leakage. In other words, a correct valve. This valve was also being customized for the purpose of this project, so therefore a better suited one would also be a very beneficial one to be using. Overall, the last part of the system that can be improved is the linkages. The linkages at this point utilize a screw and hot glue gun assembly. These areas could be variously improved by using other fixtures such as bearings or nuts and screws and bolts with washers, which would be a much sturdier design.